Welcome to StatLab.Crunch videos. This video is about section 3.2, which is conditional probability. I want to go ahead and review a couple of problems. The first problem is going to be problem number 2. So let's go ahead and read the problem first. The accompanying table shows the results of a survey in which 250 male and 250 female workers aged 25 to 64 were asked if they contribute to a retirement saving plan at work. Complete parts A and B below. They ask us to click on this. Let's go ahead and click and see what the question is asking us for. So the first question says, let me go ahead and let's see, what options do I have here? Okay, let me highlight. It says find the probability of randomly selecting worker contributes to the retirement saving plan at work. And the most important, given that the worker is a male. So when they give you something like that, you always start with, let me go ahead and show you here. You always start with that is given. Oops, wrong color. You go ahead and start with something that's given. So what is given? Given the condition is that the worker is a male. So I don't care about female or people who don't contribute. I only care about male. So in this case, let me go ahead and move this up here and go back and click on my thing and highlight. They only said the worker has to be a male. So I'm going to go ahead and highlight my male row, because the condition is given that they are male. So once I have that, I'm going to go ahead and see what my sample size is, which is 250, right? So this is going to be my sample size is 250. And what am I looking for? I'm looking for people who are contributing, which are 112. And that will give you 0.448. Okay? All right, let's go ahead and see what the next question is. I'm going to erase this, get this over with, move it down. Find the probability that the randomly selected worker is a female, okay, given that the worker contributes to retirement saving. In this case, the given condition is, let's see if I can do, okay. The given condition is he contributes to the retirement savings, which is going to be my column. So in this case, the retirement savings contribute, so it's going to be this part. Okay, I'm going to go ahead and move it. What's my sample space? 272. 272. And they said they want only females. How many females do I have? 160. And that will give you 0.588. So whenever they give you a condition, you have to make sure you look in that particular row or a column. Okay? Perfect. Now let's move on to problem number, I think I had the number. Let's see. Yes. Problem number 7. Let me go ahead and get my pen tool here. This is too big for me. I'm going to go ahead and take this. In a sample of 800 US adults, 213 think that most celebrities are good role models. 2 adults are selected from a random population without replacement. So they're not going back into the group. Assuming that the sample is representative of all US adults, complete part A through 6. So let's go ahead and see what part A says. Find the probability, I'm going to go ahead and pick a box. Find the probability that both adults think most celebrities are good role models here. So I am going to see both of them have to think they're good role models. So the first person has to think they are good, and the second person has to think they are good. When I say and, what am I doing? Multiplying, correct? Okay, so probability of the first person thinking they are good times probability of the second person thinking they are good. How many people do I have? I have 800 adults And out of them, 213 think they are good. So 213. So I pick one adult out, and that adult is gone. So how many do I have? Now I have 799. From 213, if I take one off, I have 212. And when you multiply this, you end up with 0.0071. Okay? Now, let's go ahead and see what the next one is. I'm going to erase this. The next part is find the probability that neither of the adults think that they are good role models. So I have 213 who think they are good, and I have a total of 800. So if 213 think they are good, 587 think that they are not good. Okay? So now, keeping that in mind, I'm trying to find the probability of the first person should think that they are not good times the probability of the second person thinking that they are not good. So let's go ahead and do this. I have a total of 800 adults. 587 think they are not good. Once I pick the first person, I am left with 799, right? I pick one person out from people who think that they're not good, so I have 586. When you multiply these two, you end up with 0.538. Now for the second one, find the probability that at least one of the two adults think the most celebrities are good role models. At least. So if I take away 1 minus probability of neither of the adults think that they are good role models, then I would get probability of at least one thinking that they are good role models. So 1 minus 0.538 would give me 0.462. Okay? Hope this helps. Okay, this. All right, this. Perfect, perfect. So, yeah, this problem we did in class. A doctor gives a patient 60% chance of surviving by a bypass surgery after a heart attack. If the patient survives the surgery, then the patient has 55% chance that the heart damage will heal. Find the probability that the patient survives the surgery and the heart damage heals. So here when I see the word and, I know I am multiplying. Multiplying what? Probability that the patient survives the surgery times probability of the heart damage healing. So probability of the patient surviving is 60%. Probability of healing is 55%. So 0.6, 60% times 0.55, which gives you 0.33. Okay? Perfect.